Decide if the given function is continuous. Now this is where we have to use my rules. You only have to use them in this chapter and on this problems. As most of the time you can tell. What does it mean? At x equals 0. Part A says f of 0 is defined. Well, let's see. What's f of 0? It's 0 cubed minus 2 times 0 squared plus 0 plus minus 5 is minus 5. It's defined, yes. I put in, and now what that means is I put in x and got out y. Is that true? Yes. B. The limit as x approaches 0 of f of x exists. Now remember, the limit at a whole exists. Well, what's the limit as x approaches 0 of f of x? Well, it's just f of 0, right? We plug it in, and we get 0 cubed minus 2 times 0 squared plus 0 minus 5, it's minus 5. Does it exist? Yeah. I put in 0 and got out minus 5. So does it exist? The answer is yeah. C. The limit as x approaches 0 as f of x equals f of 0. From A, f of 0 is negative 5. From B, the limit as x approaches 0 is what? Negative 5. From B. And what do I know? Negative 5 equals negative 5, so it is true. So, yep. It's continuous. It's a pain. But it's a polynomial. Polynomials are continuous. If I think about what any cubic looks like, a cubic is either an S curve or it's got two pumps. Now, did I draw that without lifting my pen? Yes. Polynomials are continuous. So would I expect the answer to be yes? The answer is yes, I'd expect it to be yes. That's a lot of yeses. Now this guy, here we go, at 2. So we need to first find what is f of 2. Does it exist? Well, 2 times 2 plus 1 over 3 times 2 minus 6 is 5 divided by who? 0. What's 5 divided by 0? Undefined. So does f of 2 exist? No. So that says f of x is not continuous at x equal 2. Now that's how further I have to go. Once it fails, I'm done. It has to meet all three. So once it fails on one, I'm done. I have to have a yes, then I can move to the next one. If I get a yes there, then I can move to the next one. The minute I get a no, I'm done. Yes, yes, yes. Well, this is interesting. And this is at -1. This is a piecewise function. So what's the only thing I need to be concerned about? Because what's the break point? The break is at -1. So if there's a break at -1, what do I need to be concerned about? Do they what? Do they meet? That's the only thing I need to be concerned about. Do they meet? Well, let's see. A. F of -1 exists. What function do I use to calculate out f of -1? Which of the two? X squared plus 3. So this is going to be -1 squared plus 3. Oops, sorry, thank you very much. White tape, white tape. Now I have to. Any problem since I'm videoing it goes down as being she did it. Now you can see she didn't. And so this ends up being what? -2? So does it exist? Yes. So that means I need to now move on to the next. B. Does the limit as x approaches -1 of f of x exist? Here I have a problem. What am I going to have to do? Since -1's a break point. I'm going to have to go both sides, right? I'm going to have to come from the left of -1. I'm going to have to come in from the right of -1. Because to the right of -1, I've got one function. From the left of -1, I've got another function. The question is, do they connect up? They could. They could connect up. So let's see. Take the limit as x approaches -1 from the left. Well, actually, let's do the easy one. Let's do it from the right, since I'm going to have to move to the other side of the page for the other guy. To the right, I have to use x squared minus 3, which is -1 squared minus 3, or -2. So from the right, it exists. If the limit exists, the limit from the right has to equal the limit from the left. That means they meet. So here we go. I'm going to move to the top of this page over here. I'm going to take the limit as x approaches -1 from the left of x squared minus 1 over x plus 1. Well, plug it in, plug it in. What am I going to do? This is going to be -1 squared minus 1 over -1 plus 1. What do I get? Which means algebra. Now, if I had a number over 0, that means I have a vertical asymptote. I'm done. There's no way those two are going to meet. If this guy were a vertical asymptote. But that says he's not a vertical asymptote. What is he? He's a hole. So now I need to do algebra. So x squared minus 1 over x plus 1 is x minus 1, x plus 1 over x plus 1. X plus 1's go, I get x minus 1. Now I can take the limit as x approaches -1 from the left of x minus 1, which is equal to -1 minus 1, or -2. So the limit as x approaches -1 of f of x is what? From the right, it's -2. From the left, it's negative 2, it's negative 2. So does the limit exist? Yes. So what do I know about the two graphs? They meet. Okay. So we're looking at, does the limit as x approaches negative 1 of f of x equal f of negative 1? Well, the limit we found was negative 2. This is part B. F of negative 1 was what? Also negative 2. This is part A. That says part A equals part B. So the answer is, yeah. The two graphs meet. They connect. At negative 1, they connect up.